This project uses Amazon Web Services to build a full data pipeline for predicting company bankruptcy risk. Below is our data diagram. We will first create a bucket inside of Amazon S3 and we'll use the glue to perform ETL and load the data into our data warehouse. Lastly, we'll build our model using SageMaker and Canvas, but first we need to create our data lake. This is where all our raw data lives. We set up an S3 bucket named MSBA Financial Group 091 where we upload both training and prediction data sets. Think of this as our storage foundation. We put our training data into our input folder and also put our prediction data into our prediction folder, and also added bankruptcy data. The financial data used in this project was provided by DataCorp and our own analyst. Next, I set up our Amazon Redshift cluster and prepared the tables to handle and transform data from our ETL process. To optimize costs, we're currently using a single node configuration. However, if we need greater performance or scalability in the future, we can easily expand the cluster by adding more nodes. Now that we have finished setting up our data lake and created our warehouse to handle the incoming data, we use AWS Glue to handle the ETL process. Glue will extract the data from S3, transform and join it into the correct format, and then load it into our data warehouse. This step ensures our data is clean and ready for analysis. This visual shows the ETL process we built in AWS Glue. We started with two data sources stored in S3, financial data and ratio data. These two data sets provided the key metrics needed for our prediction model. In Glue, we use an outer join transformation to merge these two data sets based on a common field. Next, we perform a change schema step to clean and standardize the column types and names, and then transform the data. And then finally, with the transformed data, we loaded it directly into Amazon Redshift, our data warehouse. Next, we will go make sure that our data is properly structured and ready for analytics in Redshift. Redshift should now hold our joint data set and all the company's information in our cluster that we created earlier. I ran a quick SQL query, select all from MSBA Financial, the table we created, and limit it to its first 10 rows. To review the top rows of our data set and confirm that everything loaded correctly and is ready for analysis. This table includes columns like company ID, net worth assets, and retained earnings to total assets, and other key financial ratios. These variables are crucial predictors that help our machine learning model evaluate each company's financial health. Now that we've confirmed that everything is properly set up in our data warehouse, we'll move on to machine learning. We use Amazon SageMaker AI to build, train, and deploy our predictive models. SageMaker will help us find the best model for predicting bankruptcy. We use SageMaker Canvas for a low-code approach ensuring efficiency. Here we're inside Canvas, which is the visual interface for building and training machine learning models without having to write code. Next, we'll use our labeled training data to build a model to predict whether a company will go bankrupt or not. Inside of Canvas, where we begin building our bankruptcy prediction model, this is where we define our target variable and configure the model before running exploratory data analysis. This correlation matrix helps us understand the relationship between our financial variables and the target variable, bankrupt. It's a key part of our exploratory data analysis because it shows which features are most strongly related, either positively or negatively, to company bankruptcy. Looking specifically at the bankrupt column, we notice moderate negative correlations with variables like net worth to assets and retained earnings to total assets. This suggests that companies with lower net worth or lower retained earnings are more prone to bankruptcy, which aligns with what we'd expect financially. Here we can see the distribution of our target variable, bankrupt. The majority of the observations are labeled as 0, meaning the company did not go bankrupt, while a much smaller portion is labeled as 1, representing companies that did go bankrupt. Next, we ran a quick build for this model and we'll analyze its performance for predicting companies that will go bankrupt. Here we can see the results of our trained bankruptcy prediction model in SageMaker Canvas. The model achieved an accuracy of 93.7% and an F1 score of 0.41. This visualization shows how our model's prediction compared to the actual bankruptcy outcomes in the dataset, and next we will use the model to help us make predictions on our MSBA financial portfolio. After training and testing the model, we evaluated 10 companies. The model predicted that Western Corp, Design Solutions, and Enocor have high probability of bankruptcy, between 80 and 93%. Therefore, my recommendation is to exclude these 3 companies from our investment portfolio. The remaining 7 companies were classified as low risk with 90% survival probability and are strong candidates for inclusion.